Okay, now we reach the most complicated part of matrix multiplication. Okay, now matrix multiplication, if you want to multiply two matrices, okay, there is only one condition: they must be compatible. Same like addition and subtraction, but in addition and subtraction, we are talking about having the same order. That means the same size. In multiplication, it is not. Okay, what makes two matrices compatible is the following condition. Okay, and that is the most important one. Now, matrix multiplication of A to B is possible if the number of columns of A is equal to the number of rows of B. Okay, that means to say, right, if A's order is n times P and B is P times n, that means to say, if you observe this, the P and the P are the same, right? Okay, then you can what? You can multiply, and then the m product will be a m by n, which is drawing from the first row and the second column. Okay, so for example, right, if you have a 2 by 3 matrix, you multiply to a 3 by 2 matrix, then your m product, this one can multiply or not? Can, because 3 and 3 compatible. M product is just the 2 and 2. So you will get a what size? What order? 2 by 2 matrix. Okay, so this one you must be clear. Okay, once you are clear, then the methodology. How do we multiply? Now, I want to show you this particular matrix that I talk about, 2 by 3. This is row 1, row 2. This is column 1, column 2, column 3. Okay, and you have the second matrix to be row 1, row 2, row 3, and then column 1, column 2. Okay, now how do I multiply matrices? Very simple. What you need to do is, now you know you're going to get the final product has a 2 by 2, which is over here. Okay, and let's look at the very first position, A11. Okay, the 1, 1 will give you a hint. You take row 1 multiply by column 1. Okay, meaning to say what? Okay, I give you this table, meaning to say this is a row 1, right? 1, 2, 3, right? You take 1, 2, 3, multiply by, you see why I highlight A, B, C. So your so-called A11 position is actually equals to 1 times A, you add 2 times B, you add 3 times C. So you get A, 2B, and then 3C. Where do you find this? A11 position, which is here. Okay, now how about how can you run off? Okay, which is, let me erase it off, which is here. It run off again. Okay, anyway, can. Okay, now if you want to look at the A12, A12 meaning you take row 1, see A12, right? So you take row 1, you multiply to column 2. Then what do you have? Row 1 is still 1, 2, 3. Column 2 is actually D, E, F. So you will get 1 times D plus 2 times E plus 3 times F. So eventually you get D, 2E, 3F. Where do you find that again? There, A12 here. Okay, moving on. How about A21, A22? It's very intuitive, right? So A21, A22, you are taking, say A21, A21. A21 is row 2, column 1. So where is row 2? 4, 5, 6. Column 1, A, B, C. So A21 will be 4 times A, 5 times B, and then, not times, and then plus 6 times C. So you get 4A, 5B, 6C. 6C. In which you will land yourself over here, 4A, 5B, 6C. This one. Okay. Now, last one, which is your 822. 822 is actually, no space. Okay. Row 2 and column 2. Okay, so if you look at the original matrix, column 2 is your D, E, F. So you will get, 4 times D plus 5 times E plus 6 times F. So you get 4D plus 5E plus 6F. And where do you find that? In the position of your A22 here. Okay, so this is your 4D, 5E, 6F. Okay, now you got to practice this for you to get inside your blood. Or if you're not, you will get very confused. Okay, so two things to determine. Number one, you must know what is the final. I say again, you must know what is the final order. Number two, you must know what are the elements. Okay, so with that, let's look at one example.